Okay, so let's begin. Well, my name is Mario Esteban, and I'm the director of the Center for Asian Studies here at the Autonomous University of Madrid. It's my pleasure to introduce Vincent Brussee. He's a PhD candidate, at Leiden University. He's one of the leading experts of the use, of data from a quantitative perspective, in Chinese studies, and so that's the reason actually, we've invited him to be here. And he is the author of the book Social Credit, that was published by Palgrave Macmillan in 2023, and he has previously worked for Merix, and that is the largest think tank in Europe, working on Chinese studies. Well, this is the last. Well.
I think it's working.
Yeah, it's working.
But otherwise, I think I have a loud voice anyway.
Yeah, okay, no. Yes, for me.
Point taken, it's all about me. It's all about me. I get it.
Okay, so, and as most of you know, this is the last session, of the second workshop, methodology organized by the, what happened? No, sorry. It's organized, by the Spanish Association of Asian Studies, and this is the last, session. So, thank you so much, Vincent. Don't be mad. It's not because you feel some people have to leave, before you finish, because there are some trains to take, and now the situation is particularly, a little bit problematic in Spain. So it's not because your presentation is not of interest; it's of great interest for us, But so now you have the floor. Please go ahead.
Thank you, Mario. And I think your introduction is way too kind, and I would understand if you have to leave for whatever reason not related to trains. I don't judge, okay? Because I had actually planned my introduction quite differently, and your introduction is way too kind. I was assuming you didn't invite me here because I'm some kind of expert, but rather because I'm perhaps the opposite, but I have a trajectory, I think, that may speak to a lot of the PhD candidates in this room. As I said, as Mario said, the introduction or the theme of today is about doing digital methods, using text as data research in particular. And as I said, I'm not an expert in this by any means. I came from a very qualitative China studies background myself. I did international relations, China studies. And to tell you a little bit then how I kind of wound up there, I figured I would just give you my life story, starting with this very embarrassing photo of me in 2019. Amazing, isn't it? My hair was looking better than I think it is now. But so this was when I was approaching the end of my master's degree. I was doing a traineeship in Shanghai at the Dutch embassy, Dutch consulate, I should say. And I didn't really know yet what I wanted to do with my career, but I did know that I wanted it to involve China in some form. So I was doing a lot of policy research. Here I was working on a circular economy initiative. And yeah, I just knew that I want to be in China longer. I had already plans to stay in China for much of 2020. And so obviously, when I say 2020, we know what happened in that period. And so I left Shanghai on 13 January just to go home for a quick holiday. So I thought. I didn't re-enter China until 4 years later. Like, of course, many of you, right? This is not a sob story. But so suddenly I was thinking, right, I'm supposed to be in China. I'm supposed to be in China doing field work. I'm supposed to be enriching my understanding of China and whatnot, right? And all of a sudden, that couldn't happen anymore. I was stuck in my mother's basement, quite literally. And I suddenly had to figure out what to do. How do I continue building my China research profile, my China career, if I cannot go to China? And so a couple months later, I was very lucky to find my first big boy job, so to speak, in Merix, the Mercator Institute for China Studies in Berlin. I think some of you already know what happened. In 2021, the Chinese Foreign Ministry imposed sanctions on quote-unquote relevant EU entities and personnel, including Merix, my employer, with anyone working for those institutes being prohibited from entering China and doing business with China. So all of a sudden, right, I had these big plans for my career, and all of a sudden I was stuck at home in my mother's basement, not being able to go back to China. At this point, I was, of course, already in Berlin. But all of a sudden, I was like, how do I research China if there is a possibility that at least as long as I'm working for Marx, I cannot go back into China? But at that point, there was even the thought, what if these sanctions stick, right? What if I'm never able to go back to China? That didn't happen. As I said, I've been back since. But so all of a sudden, there was this really big question for me. What do I do in this situation? And at the same time, I started to learn about a lot of opportunities that we could leverage from outside of China. And this screenshot here is just one example. This is the State Council policy database, right? It's essentially a repository of all the documents, policy documents, legal documents that the State Council, China's cabinet, has ever published. And you can just see you're talking about 31,000 documents. And at that point, you can, of course, start to imagine that you cannot read all of these by hand. I'm by no means fluent in Chinese, as much as I would love to be. But even if you're fluent Chinese native speaker, this is going to be difficult for you to parse essentially by hand, right? Let alone, you probably wouldn't want to have to read all these documents. They're really, really boring. So here I was thinking, what if we can think about ways of essentially automating reading these? How can we analyze these at such a large scale that we can start to ask new kinds of questions? Because of course, digital methods, they're not just about doing things more scientifically. I think that's what you hear a lot from social scientists. I think that's nonsense. But I think what is true is that once you are able to process these kind of quantities of documents, you can ask different kinds of questions. You can essentially take a bird's eye view and spot patterns that you just cannot spot with the naked eye. And so this was about 2020, 2021 that I kind of started to come to this realization for me. And this informed most of my career trajectory since. Most recently, I founded a database called Reading China Better, where I've aggregated now over, and this is an old screenshot, at the moment over 2.1 million official documents from China. You can apply for access if you're interested. You can just go to readingchinabetter.com if it doesn't break. I'm not a great programmer, again. You can apply and you get access to all these documents. And essentially, I'm now just thinking for every project, like how can I use this to learn something new, something interesting about China? And so I figured I would use that essentially to guide a little bit what I thought to talk about today. How can we learn new interesting things about China once we start to aggregate and analyze these documents at scale? And of course, we'll also talk about things that are not just about policy, but we can also talk about social media and all these kinds of things. But I'll be drawing from examples from my own research that are doing this. So I know that many of you are not from a digital methods field like myself, right? So my goal for today is to give you examples, real life examples of things that I've done. And if I can do it, you can do it too, right? Again, I'm not a data scientist. I'm just learning all of this essentially as a COVID hobby for me. And to hopefully inspire you, show you some things that you can start to apply yourself in some form or another. And even if you're like, whatever Vincent is talking about is boring, I want to hop on my train and figure out a way to get home. It is, whether you like it or not, it is a reality that many more fields, whether you're a traditional humanist or a modern social scientist or whatever label you want to give to it, more people are using these methods. So even if you're not planning on using it yourself, learning how to interpret it, essentially developing your own literacy in this field is so important. So I'll be giving you a couple of examples and I'll talk about what are some of the strengths, what are some of the weaknesses, what are some of the things that you can do. And at the end, I'll conclude with some reflections, I think, for all of you. If you want to embark on these kinds of things yourself, but also if you're not interested at all and you just want to know what other people are doing wrong. Fair, right? And so I have about, I think after this introduction, about 15 minutes left. But I would also say if that works with the recording, feel free to interrupt me at any time if you have any questions. I would love to stand up, but I've been asked to sit down for the recording, right? But as an advantage, you don't have to see me kind of wander around the room aimlessly while I talk. But anyway, So when I talk about text as data research, right, what I mean is essentially taking texts, official documents, social media posts, and using that as data in a quantitative sense. And there are a lot of things that you can do with that. There are hundreds, if not thousands, of potential subfields that you can think about. A couple that you can think about are tasks called similarity. So how similar is A to B, right? Something you can automate at scale. You can think about how similar is a social media post to another, how similar is one document to another. Perhaps the most common text as data task is called classification. Is this text category or class A or B? And you can think of examples like, is this email spam or not spam? That's probably not something you're going to do in your work, but you can think about, is the social media post positive or negative? Is this article about Donald Trump or about Xi Jinping, right? Those are types of classification tasks you can think about. There are tasks related to information extraction. So if you have a document, what countries are mentioned in it? What actors are mentioned in it? Again, all different kinds of things that you can do automatically at scale involving text as data. And I could talk about hours again about the kinds of different things that you can do with it. I think classification is the most common one in social science, but I think it's also the most boring one. I think it's the one that everyone does, and therefore is a bit of a cliche to talk about. I will still talk about it because everyone talks about it. But this, I think, is really the start. Try to think about what kind of problems do you encounter with the materials that you work with, and what kind of text as data approaches could map onto that you could do automatically. And so in the remainder, let me give you one example of each and really talk through it in detail. So the first is similarity. And if you think about similarity in a kind of intuitive sense, right, you can probably judge quite simply that, you know, these two bottles of water, they are similar, right? I mean, they have a different cap, but these are similar things. But how would you ask a computer to identify whether two things are similar? Let's do a little exercise together. See if we can all wake up from our post-lunch slumber. Trust me, I ate too much food as well. I know what it's like. So how would you define and in the next step measure similarity between this sentence, this is a sentence, and sentence 2, this is an entirely different sentence? We know that these sentences are similar, or somewhat similar. So how would you define or measure similarity if you have to think as a computer? How would a computer understand similarity between these two sentences?
Same words.
Same words, for instance?
Structure. Structure.
How would you measure structure?
Well, there's a subject verb object structure.
More like linguistic grammatical kind of structure?
Yeah.
That's not as commonly done, I think, in text as data research because it's more difficult. But definitely there are techniques actually in computer science that can do this. I'm forgetting the name now, but there are tools that can allow you to identify what function a word acts as in a sentence. These exist. They're more difficult to operationalize if you want to measure similarity. Any other ideas?
Maybe the subtext or the context of the sentence.
How would you measure or understand that?
Like for example, institutional report or something like that, which use very specific words and in a very specific situation. So maybe it's difficult for a computer to understand the context, but maybe if you add some information, extra information, maybe the machine could analyze that and find some similarities between the different texts and sentences.
Yeah, in this case, you would essentially be talking about metadata, right? Is for instance, if these two sentences are both published by, say, the state council. I mean, I don't think they would do that, but as an example, exactly. I mean, those could be things that you look at to understand similarity. Are they issued by the same agency or something of that sort? Any other ideas?
The length of the sentence,
Exactly, yeah.
the topic of the words, for example,
Yeah.
talking about weather places.
Yeah. Yeah. You can already hear there are many different kinds of ways of essentially skinning a cat, right? Many different ways of approaching the same problem. And this is where it becomes interesting, right? Because if there are so many ways of understanding similarity, what would you do? There's actually one more that I also want to tell you, and that is called edit distance. How many edits do you need to make to arrive from one sentence or one string to another? So in this case, that would of course be you have to turn A into N, one edit, and then you have to add two different words, which would either define as new words or as each individual character that you have to add those words. But so there are a lot of different ways of understanding similarity. So with that little kind of brain teaser behind us, let's think about how we can use similarity then as a research tool, essentially. I've recently done a project where I wanted to measure policy change using similarity. You can imagine policy change, that means change from one into another. How similar is one from another? And so what I looked at was the process of public policy consultations. If you know your Chinese policy making, you know that the government often releases draft regulations to the public. The public can, submit comments, and the government will perhaps do something with it. Perhaps it won't, But so you get already an impression that, okay, so there are draft documents and there are final documents. We can start to measure similarity between those. I like to do digital policy, so I was particularly interested in cyber regulations. And so I simply wanted to know is when does this process of consultation actually result in policy change? And so here's what I did. I went to find all cyber regulations that are issued by the China Cyberspace Administration. And I simply created a data set. I did this manually because there were only 25 of draft and final pairs. I measured similarity, and I took that essentially as my independent variable. I want to understand what factors change similarity. And then I look at what factors shape that variable. So what dependent factors, essentially. And so, like what we discussed, I had to make a decision about how do I measure similarity. And there are many different ways of doing that. None of them is inherently better or worse, right? You can imagine that each way of measuring similarity is equally valid as one another, but you have to interpret these results in a different way. Here's what I did. The first measure of similarity I took is called cosine similarity. And I'm forgiving you for not knowing this one because it's a bit nerdy. There's some mathematics behind this. So imagine that you have two strings of text, right? The A and B. And that first string, it consists of 3 words: requirements, engineering, and another time requirements. And what cosine similarity does is it essentially plots them on an x and y axis. So, 2 times requirements, 1 times engineering. So you draw a dot here. Sorry, Mario, I had to stand up. And you have a second string for requirements in engineering. You draw a dot as well. And then you can, of course, draw a line from the simply 0, 0 to both of these dots. And then you get what we call your cosine similarity. The cosine similarity essentially... oh, this is fine. So
Yeah, okay, if you want to point, you can.
Oh, yes, that's a lot smarter. So your cosine similarity then kind of becomes the angle between these 2 lines. What would be a downside of this way of measuring similarity? If you think about it as the angle between 2 lines.
Should I mention something?
Yeah, I mean, in practice, it of course looks a lot more complicated than this.
Distance of 2 concepts or something.
What do you mean by that?
I don't know how I can explain that. The perception of something. Okay, I don't know how I can explain that. Like, for example, there is a concept, and someone uses this concept in different contexts.
Yes.
And there is a perception. So you can see in this graphic how the people understand that. But I don't know how can we. measure. So
If I may paraphrase or in any case, one of the options that could come from what you're saying is indeed, it assumes that words are always used in the same way. So it doesn't matter if requirements mean something else altogether in that context. It's all measured in the same way. And this kind of similarity could not account for that. So that's indeed one. What were to happen if I have another sentence that is 4 times requirements, 2 times engineering?
It will be like the same line, right? Because it will be 2 and 2 and 2.
It will be the exact same angle
Yes.
as string A. So in other words, you can double the length of a sentence, but it's the same similarity. And so how would you understand in this kind of similarity? It's not a good representation of how really similar two documents are, but of how topically similar they are. They discuss the same thing, roughly, right? Because they use the same words in the same proportions, but they may do so in a completely different way. It's an interpretive difference, essentially, an interpretive choice that you'd have to make.
Sorry,
Oh.
may I ask a question?
Please.
Why these words? These are the archetypical words used in the kind of data you're working with?
This
What
is just
happens
a
if they
random
go
example.
Out of you get an example that goes out of this specific vocabulary, then it's out of your process of analysis.
So in this specific case, I mean, this is an overly simplified example.
Yes.
Essentially,
So we're talking about, for example, as a standard, not 3 words, but 1,000 words, or there is a specific ideal number of words depending on the long.
it can use as many words as you want. So often what we would do, we would select only, say, the most common words or the X% most common words. Perhaps we do accept a couple stop words. We make a lot of decisions in the process. But technically, there are some mathematical formula that essentially transform this principle onto hundreds, if not thousands of words. I'm not a mathematician. I cannot explain that to you.
Neither I am, so
but,
I'm grateful for that.
Yeah. I'll promise you I will not talk about coding. I'll not talk about maths today. Part because I am not that good at them myself either, but also I will use it as an excuse to keep it easy today. But yeah, absolutely good question. Another one is, I think, what one of you mentioned, which is about how many unique words are shared in a text. So essentially, it looks at the unique words in A, unique words in B, and just looks at, what's the difference. You can imagine that this also comes with its limitation because it only looks at unique words. So it's very sensitive to individual changes in a text, but very insensitive to how long a document may be, or very insensitive, again, to how often these words are used. So I had to choose between these two, and what I did is I used them both. And that's what you often have to do as a data scientist is, indeed, all of these measurements that we're using, they're imperfect. But what if you just use both and you show that your results are, as we call, robust, irrespective of what specific measurement tool that you use? So let me show you a couple of results. One of the things that I wanted to look at was how the sensitivity of a policy, so how politically sensitive is this issue, how that would affect similarity or dissimilarity in this case. So I manually classified these topics or these documents according to how sensitive I think the Chinese state sees them. So very high sensitivity, you could imagine things like, online content management, censorship. I classified these as high. And the things that are not as sensitive, personal information protection vis-a-vis companies, data exports, perhaps not as, somewhere in the middle, AI regulation, again, not as politically sensitive. And what you see is that the more politically sensitive, the lower the similarity, in other words, the more change, right, from draft to final version. Perhaps it's a bit of a no-brainer as as an answer, but here you have it in data, right? And what you also see is you see Jaccard similarity on the left, cosine similarity on the right. Although the precise patterns, although the precise empirics, they differ, the pattern, lower sensitivity means lower similarity. That is the same with both. So I show my results are robust regardless of what specific tool for measurement I use. And another thing that I was interested in was how the complexity of a topic would be, or the bureaucratic complexity surrounding a topic would be associated with change. And I operationalized this by looking at how many issuing agencies were involved in drafting a policy. And again, regardless of whether I use cosine or Jaccard similarity, there's a pretty neat kind of linear regression fit that shows, indeed, the more issuing agencies that are involved in a topic, generally speaking, the more change will we see during the public consultation process. I'm not showing you this because I think it's a brilliant study. I mean, you can read it if you want in detail. I also have all the code and all the data sets available there if you're interested. But again, just showing it to you as an example of what is possible. And I will not linger on the implications and all of that stuff because that's boring. I'm here to talk about methods. And so from there, we can then take a look at some other tasks, right? And as I said, classification is perhaps the biggest task that you see nowadays. And classification, as I said, what it does is it sorts data. So say a number of social media posts or a number of documents or whatever you can imagine as your data into groups called classes. So I already showed you these two, right? Spam or not spam. Positive or negative sentiment vis-a-vis whatever it may be, right? The state, vis-a-vis a policy. What topic a news article is discussing. These are types of classification tasks. And you can imagine as many as possible, really. And there are a lot of potential approaches that you may or may not have heard about before. The most common that you'll hear talked about, and perhaps one of the more advanced, is called supervised machine learning. Machine learning says the machine learns how to sort into classes. And how does it do it? That's the supervised. Because you give it a wide range of examples. So say I want to classify social media posts into positive or negative. I write this kind of machine learning algorithm, or rather I download someone else's machine learning algorithm. And I give it, say, 1,000 examples of social media posts that I classify positive and negative myself. And then based on these examples that I give to it, it's essentially gonna learn. So for instance, if it sees that all the social media posts that I labeled as negative include Donald Trump, then it's gonna infer, oh, Donald Trump is associated with negativity. So in the future, when I see new posts or comments or whatnot that mention Donald Trump, I'm also going to more likely infer this as negative, right? That's supervised machine learning. It's not that difficult because you don't have to write all these mathematics yourself. You just download someone else's code, which is 90% of work anyway. Nowadays, ChatGPT can write a machine learning algorithm for you. It's not that difficult. But if you want to keep it even simpler, there's something called a dictionary method. And a dictionary method works a little bit like this. It is named after a data type, and the data type looks like this. You have your dictionary, and the dictionary consists of, for instance, the topics that you want to classify. And each of these topics that you want to classify is then associated or defined by a list of keywords. So say we can imagine topic 1, Donald Trump. It's associated with ice, orange, the color. I don't know. What will we associate with Donald Trump?
Narcissism.
Narcissism. You know, all these kind of keywords we associate with Donald Trump, and we want to classify texts that mention narcissism a lot to associate it with Donald Trump. We can also then think of topic 2, let's call it Xi Jinping. Anti-corruption, military purge, right? Any keywords that you may associate with Xi Jinping, you simply define your topic 2 Xi Jinping as these keywords. And essentially, this doesn't require any difficult programming. It doesn't involve any difficult kind of mathematics. It just requires you to come up with a really good list of keywords that you think are very neatly associated with your topic. And then what you simply do is you count how often those words appear in a text, and whichever topic appears most in that text, defined by keyword mentions, that becomes your topic. A really simple approach and something that you can try at home within a day. Like you learn a bit of the basic syntax, or you ask ChatGPT to write it for you. You just need to do the keywords and do it yourself. And now this method isn't perfect, but it's very useful in many cases. So let me give you one example, again, from my own work. This one is forthcoming.
Sorry, you mentioned before, right, that there are algorithms written, but there are also many dictionaries, right?
Yep.
That you can, because you don't need to build necessarily your own dictionary. You can also resort to other people's dictionaries. I mean, I just want to let you know to be aware that it could be simpler than it seems.
That's true, but I would not recommend using pre-made dictionaries because dictionaries work really well when they are used and designed very specifically for the purpose that you are using them for. Because we're just talking about associating orange with Donald Trump, and in some context that may be very accurate, but in some context that may, this orange or that orange, right? So you need to make sure that your dictionary is very suited for the task at hand, and therefore, although you can indeed download things like sentiment dictionaries, they become very messy when you don't fine-tune them for the task at hand.
Yeah, but it's not the same fine-tuning something that someone already has that to build it from scratch, right? I mean, but yeah, I fully agree with that.
A dictionary is as simple to do it yourself, really. I think it's easier to do it yourself because you have complete control over it than to or as easy. But we can talk about how this works in practice, right? So this is a project that I've been doing, which is about the China Heroes Network. An amazing piece of online infrastructure. It's a website run by China's Ministry of Veteran Affairs about the commemoration of martyrs in China, right? So people who died while giving, or while trying to serve the country in some form or another. And one of the interesting things about this website is that it has the complete records of all 1.9 million Chinese martyrs in existence, at least insofar officially recognized. And so you see all these names, right? And so, of course, when you do this qualitatively, you can read through it and you can get some useful insights. But if you really want to know who these 1.9 million people are, you're going to need to do something different. Also fascinating about this website is this. Every one of these 1.9 million martyrs, you can commemorate in an online portal like this. So once you press this bow button here, this man comes in. So you see in the middle, right, the martyr that is being commemorated. This was a fighter, I think someone who died in the border skirmish with India. This is the website, and this is all really, this is of course fun and giggles, but this is also very real. I was in Chengdu over the summer, and I saw people going to these martyr commemoration sites, teaching their kids how to bow, like what this guy did, like in that exact same formal structure. Like this is a really big campaign, as fun as it may seem. So obviously, I want to classify these martyrs. I want to know more about them. And so, of course, I retrieved these 1.9 million martyrs. This was the difficult part, actually, and I will not talk about how that worked. I hate working with Chinese websites. They're the worst. And then my first step is to then develop these classes of interest, right? So this is something that you have to do yourself. You have to think, how would I like to classify these martyrs? I'm probably not by sentiment, right? I want to classify them, for instance, by their occupation. What was their job, or what did they do that made them be recognized as a martyr? So I settled on military, official, police, commoner as kind of the types that I was interested in. And in my case, I use a dictionary model. So I assigned keywords that I think are associated with these jobs, like the military, for instance, like soldier, sergeant, squad leader, squadron, fighter, pilot. These kinds of keywords I assigned to each of these topics. Commoner, I for instance chose student as a keyword, or doctor as a keyword, like those kinds of things. You can of course also just label a lot of examples yourself and do it machine learning. Both work, right? But what is important is that you validate. Sorry.
I don't understand very well the difference between the second point and the third point, because like the keyword could be the class maybe.
So the class is say the topic. So the military is the topic, or the class I want to give to the occupation. Mm-hmm. And the keywords are essentially the keywords that I use to identify whether a description, a text, belongs to that class. So for instance, what would be the case in a situation like this is you would have a text of, say, like a paragraph. And that paragraph describes what that martyr did in his life. And then what I do is I cannot identify immediately this is military or this is not. So I do that based on the presence of keywords. So I define my topics or define my classes, and then I measure whether or not they appear based on how often they mention certain keywords, these descriptions. Does it help?
Yeah.
Right. And again, if there's anything I leave unclear at any point, one of the most difficult things I think about doing this work is not the programming, it's not the mathematics, but is that it comes with its own vocabulary. It's almost like talking to aliens sometimes, the types of vocabulary that you have. So again, if I had to, it's almost like a socialization kind of regime to get into this. So if I leave anything unclear, please interrupt me and we'll follow up in some form.
So just one step I just want to confirm, because you said develop cases of interest, this typology means very official police, and assign keywords. So actually you need to, let's see, read 200-300 first to set the types of martyrs you have, afterwards to set the keywords.
Very, very good point. Indeed, how do you indeed make these keywords? And exactly this is what I did. So I looked at a lot of examples myself. Based on that, I developed this kind of typology of what I was interested in, these classes. And then I also used this close reading to identify which keywords are accurately representing that kind of class. Very good point, absolutely. Yeah. Perhaps this is also a lesson, right? You're never replacing manual work. Yeah. Because even if you do this machine learning, you're going to have to hand code, say, a couple thousand examples yourself. You're still going to be doing things manually. It's not replacing it in any form or sense. And of course, what you then want to do is you want to actually, once you have defined these keywords, especially if you're looking at a couple hundred of these examples yourself, you want to validate that it does what it's supposed to do. So you then want to, again, go and throw out a couple hundred examples of what your dictionary essentially classified and say, is this correct? Is this not correct? So you're still then going to be what we call validating whether your model works or not. Get back to this in a moment. After I did this is an outcome. So as I said, I classified by 4 types, as well as unknown. In some cases, there was no information about the martyr or not enough information to judge. And so what you see is that essentially in the entire Mao era, the military is by far the biggest group of martyrs. And it makes sense, right? Soldiers. But since the 1980s, China hasn't had major military conflicts. And so you see then also a shift towards recognizing people from essentially all walks of life as martyrs. People who jump into a lake to save a baby and give their life in the process. People who save others from fires. And so you see that the share of the military as martyrs is decreasing, and there's an increasing push towards recognizing martyrs from all walks of life. Doctors during the COVID-19 pandemic, all these groups of people. Again, I'm not showing you this because I think the research is amazing. I'm just showing it to you as an example of what you can do. And this is a really straightforward, simple example to look at. But class definitions are a really big thing, because how do you define your classes? And indeed, you have to then read a lot of these things yourself to come up with classes that make sense. And there's a rule for this: mutually exclusive, commonly exhaustive, MICE. And that means that you must define classes that are mutually exclusive. They may not overlap, because if they overlap, everyone gets confused, right? What does it really mean? How can you assign keywords to things when they overlap? So you must define classes that do not overlap, but that together are commonly exhaustive, so that there's not a single data point in your data set that cannot be assigned to either of those classes or any of your classes. You can take the easy way out and have a residual category, but that becomes messy very quickly. And so you're gonna end up spending perhaps days working out a code book where you define rules. If this, then it is that. If that, then it is that. These are all the potential boundary cases that I may encounter. Again, a lot of manual work. And in the end, if your classes aren't clear, a machine learning model cannot learn if it's unclear. The interpretation of your results becomes impossible. You cannot assign reliable keywords. Again, a lot of manual work that goes in. I'll skip this point for the sake of time. The second point is then validation, because even if you've given 1,000 examples to your machine learning model, how do you know that it actually has learned the right thing, right? And so there are a lot of metrics for this, precision recall. I'll not dive into too much detail. You've perhaps heard a lot about it during COVID-19. But you can also use a more simpler version, and that's a confusion matrix. Confusion matrix, I realize this is a little bit small for you, especially in the back. But this was a real project that I was working on, and I wanted to classify policy texts. And I wanted to classify them by how they were referring to a specific industry. I wanted to know if they were designing funding instruments for that sector. I wanted to know if they were more broadly indicating support for the sector, or if they want to regulate it. And I had a residual category for any references in policy text that were not really expressing anything particular about that sector. And so you see here, there are 29 cases where the text was actually a funding instrument and where my model also predicted a funding instrument. That's essentially what this matrix is showing. And so there are 189 where it was actually promote and where my model also predicted promote. But there were also 3 cases where my model predicted promote, but where it was actually a funding instrument. And so confusion matrix like this can show you how well your model is performing. If you look at this matrix, would you say my model was performing well? Sufficiently well? Would you dare to use this model?
Well, kind of, right? Because you have, it's like the diagonal that you need to see. It's 21 of 30 something, the first column, then I think there's a lot of, kind of, it's true that you have that one, that 24, I don't like that.
This one is a bit problematic indeed.
Yeah. But besides that,
would you dare to use the model?
well, which is the bet? Perhaps. Yeah.
Would you put your publication on a line with reviewer 2? In this case, actually it's sufficient. You're talking about what we call an F1 score, which is the aggregate of precision and recall, of 75%. And so 75% is not great. It's not great, but it's also 3 times better than randomly guessing. And often when you're making arguments that are about broad scale patterns, rather than about very specific issues, then this can be sufficient. Ideally, you'd get it above 80%. 80%, I would say, is the threshold from which you feel comfortable using it. So I ended up, this was using a dictionary model. It didn't perform well enough, so I ended up coding a machine learning algorithm that got to 81%. At that point, it was good enough. But so those are the kind of questions that you want to ask of yourself when you develop a model, right? But let's do an exercise. Explain these predictions. So assume that this is a machine learning model that is classifying whether a picture is a wolf or a husky. I know I promised text as data, this is images as data, but and you can see it's getting 2 wrong. Why? The snow? Yep, exactly. So you were very quick. I was hoping this exercise would take people a little longer. Very nice. But so this is what is happening with the machine learning model. The machine learning model learns based on patterns. And in practice, it was only seeing the snow in the background and not actually the wolf or the husky. And this is an extreme example, but there are real cases in science where these kinds of things have gone horribly wrong, wasting hundreds of thousands of euros in the process. A recent example, COVID, again, I'm sorry, was that scientists tried to develop, also based on images, a model that would distinguish severe COVID cases versus mild COVID cases. Great goal, right? So sounds very useful. The only problem was that their test data was similarly biased. The people who had severe COVID, because they had severe COVID, they had to be laying down in a hospital bed. And then they took the X-ray of those people. But people who are perfectly healthy, they don't need to lay down to take an X-ray. And so what happened was that the model learned to distinguish people laying down from people standing up. And therefore got all of these issues wrong, rather than actually learning correctly And this is one of the big problems with machine learning models, is that even if sometimes your precision and recall on your testing and training data set is really, really high, your model seems to perform well on the data that you've given it. Does that always correspond to the real life case that you're trying to apply it to? And of course, if you just want to, if your training data is the same as what you're then applying it to, that's no problem. But when that is different, that can become a big issue. So apparently that example was too easy for you, but I'm glad that I then don't need to dumb it down too much. The last task I want to show you is information extraction. And as I said, I think classification is entirely overrated as a problem, and I'm really into information extraction. This is a government document, right? This is the planning outline for the establishment of the social credit system, a boring document. I wouldn't want to recommend you reading it. But a document like this contains a lot of fascinating details that are trivial at first, but become really interesting once you look at it closer. Such as a document number. This 21st document in the series of WOFA from 2014. There is, of course, information on who has issued the document, the State Council, what kind of document it is, an outline and going out. The list goes on of interesting different things that you find in these documents. And so here is what I was interested in. I wanted to measure the transparency of China's government. And transparency is another, like similarity, is quite a vague concept, right? Like, how do you define that? There are some things that you can start to think about, but you're probably going to have to measure it through some proxy. You cannot directly say, oh, this is 90% transparent, this is 70%. You're going to need to come up with some proxy. So my idea was to look at these document numbers. The idea was that if we know that all of these documents are numbered and serialized, we can start to put something like this together. We have number 2, number 3, number 7, number 8. But hey, where's number 1? Where's 4, 5, 6, right? And so suddenly you can think about, okay, well, we cannot perhaps measure transparency perfectly, but we can measure the percentage of documents in a series that, in this case, China State Council is releasing to the public, or this is the General Office of the State Council. As it turns out, you then first start to ask how many documents are there in total, then what percentage do we have access to. Those become really simple calculations once you start to extract that. And as it turned out, this is not a new problem. This is called the German tank problem. During the Second World War, the Allies wanted to know how many tanks the Germans were producing every period. And of course, they had spies in Germany, they had their intelligence analysts, but they were coming up with immensely varying estimates, often very positive for the Germans, estimating that the Germans were producing insane numbers of tanks still, even far into the war. But, as we know, with the Germans, they like to do things bureaucratically. They number everything, including their tanks. And so what the Allies started to learn was, wait, we're just going to look at the numbers of the tanks that we've destroyed. It says here tank number 30 we've destroyed, tank number 50 we've destroyed. And we're going to extrapolate from that to see how many they're actually producing. As it turned out, that was the most accurate estimate of how many tanks the Germans were producing during the entire World War. It was far more pessimistic for the Germans. But they verified with the records, of course, afterwards, because again, bureaucratic Germans, they kept their records even after the war. This was the best estimate that they got. And so then the only thing you need to do is essentially extract all of these numbers at scale. And there's a really simple tool for that. How far are we along in terms of time? I think I'll round up soonish. So then I'll skip the precise tool using for this, but this is regular expressions. This is one line of code that allows you to identify all possible variations of that document number. All the numbers, all the years, all the variations on the same style. As I said, I'll skip the details. It's here for the recording now if you want to watch it later. Mm-hmm. It's really simple. It's really that one line of code that captures all the documents. But then the result is something like this. You can map it over time and you get something really simple and straightforward. that showed that government transparency increased even under Xi Jinping, at least as understood by the percentage of documents that were released, but started to decline in somewhat more recent years, especially starting 2020. And this is an old study. This was published with Merrick's in early 2024. I heard of some colleagues who repeated my analysis that it got worse since. Whether that's good or not, I'll leave it up to you.
I think the last numbers were about 40%, something like that, in the data conference.
Yeah.
40%.
Yeah, and I've described this, the methodology, and again the code as well in more detail here if you're interested. It's there in open access. But so these are just a couple of very simple examples, I think, that you can start to use. You say you take 1 or 2 days to learn the basic syntax of Python. Once you've done that, applying these methods takes you a couple of days with the help of ChatGPT maybe, but all of this you can really start to learn really, really quickly yourself if you're interested. But what are things that you should really keep in mind before you do so? Let's conclude on that. The first thing is about ethics and perhaps more broadly responsible research. I'm aggregating millions of Chinese documents, and I'm pretty sure the Chinese government does not like that. I mean, I don't think the Chinese government itself cares about me, but I'm pretty sure that they don't like people like me in general, in an abstract kind of concept, aggregating all of that information outside of China. That's perhaps also why this transparency is decreasing, right? So on the one hand, you need to consider what are the potential security risks for yourself. If you are just doing it for your PhD, you're perhaps publishing 1 or 2 articles, you're probably fine. But if you make a career out of this, you start publishing on sensitive issues, then it's not just what you write, but also the data that you aggregate, the data that you share in your methods, your appendices, that can become a security concern. And this is something you need to think about when you do that. The second thing is that we know that the Chinese government also takes down data after it's been published. So you need to take measures to ensure that they perhaps do not detect it when you are scraping all this information, obtaining all this information from the internet. You may even want to consider when you write a methodology to be somewhat abstract in how you get your data and only provide it in an appendix for the reviewers that is not being published later. To say, hey, this data is so sensitive, I don't want it to be taken down, so I'm only going to describe it in vague terms publicly. This is difficult, right? Academic publishing, it sometimes puts requirements on you for that. But these are things that you want to consider from the start, not just at the end. And then, of course, like what I showed you with this government transparency issue, we know it's China. The data is not transparent. The data is curated. It varies in availability, kind of missingness as a general thing. These are things that you need to take into account, and you need to think about, how do I mitigate this? How do I know what I'm missing in my data set, such as by measuring document numbers or whatnot? And these reasons do not need to be political. Sometimes a city simply has not invested as much money in government disclosure because they're poor. And then you get 2 completely different disclosure patterns in 2 neighboring cities. These are the kind of things that you need to think about. And with qualitative research, we are quite used to kind of dealing with this, right? The historian's toolkit, you always think about how is this data being produced and whatnot. I think it's something that's easily forgotten in doing digital research. And making sure that these results are robust is so important. And then lastly, allow me to share my golden rules. The first is, I think nowadays we all talk about these big fancy methods, and that's fine. But in the end, all that matters is that the tool that you pick is appropriate for the job at hand. And it can be a really good tool, but it can also be as simple as a dictionary method. So in the end, it's not about how fancy is the tool that you use, but how do you validate that the tool works, such as by showing these confusion matrices, by measuring precision recall, by doing manual spot checks and disclosing them, all these kinds of things you need to prove. But it also just shows that you can get away with doing something really simple if it works. And that's all that matters. And so don't get into this kind of line of thinking where your methods become an end of itself. I think you see that in social science, right? Social science thinking, fancier research tools, but in the end, it may not matter. And that's what you need to be careful about. And that's what I mean here, right? Methods serve your analysis, not vice versa. don't go running into Texas data research because it sounds fancy. I think the value is because you can start asking different kinds of questions. Third is understand your problem first. I mean, it's really like it sounds nice to start using a ChatGPT or BERT-based classification model, but sometimes you don't need classification. You need similarity or you need information extraction. And so really thinking about what kind of problem am I facing here? I think that's really crux. I mentioned this one already, right? Big N isn't inherently valuable. I think in many cases, actually, it's better to take a smaller data set where you can validate that the data is reliable than trying to come up with some kind of cross-China comparison when the data is just so messy that you cannot get anything useful from that, right? That happens a lot, and that's something to be careful about. And lastly, from last slide, to think about the data that you work with. How is it produced? What is missing? What is there? All these kinds of things. Really important to think about. That's where I leave it here. I hope that gave an accessible yet still hopefully interesting enough introduction to this world of Texas data research. I'm sure we will talk more in a moment, but also if you're interested later, feel free to reach out to me in any form. I'm happy to chat about anything, share resources if I have them, anything that may be of use.
Thank you so much, Vincent. So I think now you've realized that I was right at the beginning when I said that he was an expert, right? So because you know what I meant, you know, is that definitely not because you're like a super complex data scientist, but the point is that you know many times when we go for area studies, it tends to be or traditionally been associated with qualitative, you know, kind of methodology. And as you showed to us, you know, well, not just you, but here, not in this particular moment, I think we can do also area studies, you know, using quantitative, you know, methodology. And this cannot be only used for the Chinese context or not only used for social scientist research, but you can do this in many other kind of areas, you know, just using these three kind of differentiation, you know, that you mentioned. So I think that, or I hope, in a different way, you know, that also for some of you who are from humanities, you know, I think this kind of presentations can help you to think about, you know, these other kind of questions that you can start to pose in your field when you can resort to this kind of methodology. That is not the methodology that most of the papers or most of the training that you have had before, you know, it does. You know? So I don't know if there are more questions. You know, for me it's been very fascinating. Maybe I can ask some question later, but I don't know if someone has some questions.
Friday afternoon is dangerous. After
No worries. I will go myself. You know. Okay, maybe I'm fine.
Thank you very much. It was fascinating. I have a question. I don't know if it's actually an extremely bad question or a good question. It's because you work specifically with government databases, so you more or less have a very clear frame and almost, let's say, a number of documents you are going to work with. But let's suppose that actually you don't know the total amount of documents that exist. How do you know the minimum data you need to prove a point? I mean, I give you this personal example because I try to work as well with quantitative data.
Yeah.
I was working with publications in Japan during 500 years span, and I had a huge number of publications of the database. But actually, we don't know the total amount that existed really. So I got 5,000 documents, but we don't know if there was 10,000, 1 million. So I could not prove to the people that 5,000 was good enough. In this case, you have a specific, this numeration and everything, so that makes, let's say, relatively easier to work with data. But what if you don't have this kind of very specific set of a clear idea of the amount of data you're working with? Did you ever have this kind of situation?
First of all, I mean, it's a really fascinating question. I don't have a fixed answer. I mean, with the martyrs, I didn't know how many martyrs there were exactly on the website. I knew that officially there were like 1.98, but I was able to find far less on the website. So I also had this issue of, is the website incomplete? Is there an issue with my scraping
But
methods?
you have this 1.9 million as
Yeah.
a reference.
Yeah, and so that's still different. I mean, the thing is, these document number strategies, they don't always work. So I know, for instance, my student assistant just helped me validate how many of these government documents actually mention a document number. In many cases, in this case with the State Council example, they were all mentioning a number, but there were also many cases where there simply is not a number. So in that case, you don't know how many there are in total. So these kind of scenarios, they are familiar to me. And yeah, then it becomes a question of how reliable do you think your data is? And then you need to get into all kinds of questions of, can I cross-reference this with other sources to find whether this is reliable? Can I find like any information on how these documents are being produced, and can I infer based from that? There are no fixed strategies for that.
So there's no like a German tank problem situation way to fix it.
No, in many cases there is not. There's one other trick that I actually used in that same paper, and that was that I knew that documents were referencing each other. Interestingly, they even did so when the other document was not public. And so I could infer what kind of documents I was missing, and I did a content analysis on the titles of the documents that were missing to then infer logics what topics are being disclosed less often, because those document numbers, they don't tell you anything. So yeah, I mean,
Those are China Quarterly.
China Quarterly, yes, yeah. So they're typically, if you're lucky, like me in this case, there are these kind of good approaches that you can use with a bit of creativity. In many cases, there's not. And then you're gonna need to make judgment calls based on imperfect information.
Or cross qualitative and quantitative research.
That can, yeah. Although you could argue that with qualitative research, missingness is a problem as well. If you don't know what's not in your database, you also, the qualitative analysis is also difficult, right?
Yes.
So
Yeah, but if I may jump in here, but maybe in this particular case, I don't think the point is how representative is your data set from the actual, pool of production at that point, because you cannot, affirm that at 100% rate of certainty. But the important thing from my perspective is, can you have a better data set than the one that you already have in order, to ask the questions, to try to put the points that you are doing with your paper? I think that's more, a more productive approach, to your research than the other one. I don't know. That's my thought on that, because.
Yeah. Although there could, of course, be cases where a bad data set is worse than no data set because it gives you the wrong insights, right? You can better not. So you still go back to the judgment calls, and then I mean, social media is a really big example, right? With Chinese social media, you never know what is censored, so you can never say that what you see on social media is representative of true public opinion, but you can say it is representative of the range of tolerated public opinions. So you have to interpret your data differently, and that may invalidate the type of question that you want to ask, but it can open a new range of research questions. Judgment calls based on imperfect information and unsatisfactory answers.
Yeah, and also, the missingness. You mentioned before, for example, in your case, you can see whether some periods, for whatever reasons, are more prone to missingness, or regionally in Japan, some areas for some particular reasons were more prone for missingness.
That's what they did. I looked for fires in the big cities in Japan, and I check if I could see the fires. I mean, the scene on the production of books, and kind of match. So I consider this is representative somehow. Did convince my boss, but it did convince me.
Nice, yeah. Creativity, right?
Yeah.
I mean, but they're fun problems, I think, to work with as well as a researcher. I mean, it's tough, but it's also interesting to come up with these creative solutions.
Okay, maybe we can ask, the audience here, if we just do it the other way around, instead of them asking you, maybe you can ask them, I don't know, like things like how many of them are using, this kind of methodology or have thought about using this kind of methodology?
Or
Right?
you've asked a question, so I'd be curious. Any, I mean, Black, I know you, of course.
Well, I'm not. Well, I'm starting to think about it because it's during my master thesis, I studied a little about the similarities around 3 different documents. There were
Nice.
the different approach around the free and open Indo-Pacific, about the United States, Korea, and Japan. And I want to get back to that, and perhaps I'm going to use this kind of dictionary to try to compare the different styles, for example, with the repetition of words, because I didn't do it, I just look for some messages, but perhaps to try to analyze how many words they dedicate to this topic or that. So I think it has been really interesting.
Are there any barriers that you feel right now? Are you interested at all and you're just like, this is difficult, I don't want to get into it? Or is it more like judgment in the sense that these quantitative people, they think they're scientists, but they're all just like us? What are kind of your own judgment calls, so to speak, about how you relate yourself vis-a-vis these methods? How do you see that?
Like the last ones you talked about, I kind of understood, but the cosine one, way above my head.
Yeah.
Like, way above. I really didn't get it. At the end, like with the Gonzalo, understanding that the more words you get, maybe the more research you can have, yes. But that one, it's a little bit out of my reach, at least for now.
Honestly, the precise maths, as I said, they're also still unknown to me. I just know, and I think in the end, the question is, of course, does it matter if you don't precisely understand how it works, if you know how you should interpret it?
Yeah, no, that's...
Because, like in this case, I don't know the precise maths behind cosine similarity, but I know that I should interpret it as more like a topical similarity, that it doesn't represent anything about length, but about how many, what is essentially the proportion of words that they share. And I think if you understand it like that, and you're sure that your interpretation is reliable, a big deal, of course. But often you don't need to know the precise mathematics. I think 99% of people who now use code in general, but like a machine learning model, how many of those do you think can actually code a machine learning model from scratch? Barely anyone. Even the people at OpenAI, I assume, do not know exactly how they coded their algorithm, right? It's the whole idea of these algorithms being black boxes. In the end, it comes down to being able to use and interpret them, but not knowing every single detail about them. Just like in the same way, you know how to use a car, or many of you do. I don't have a license, but you don't know exactly how your combustion engine works.
That's one of the good things of living in Leiden, that you don't need a car, right?
Yes, a town of 130,000 people. Yeah. Yes. Yeah.
Can I ask you a question?
Of course.
Yes.
Please.
Yes. You said based on your assumption that the data in China that is even public do not be transparent, or it could, well, because it's the data that is public on the websites already has the censorship.
Yeah.
So based on this, based on the data you gather, selected from the web, and then the result that you get from the data, I mean, it's already based on the data that's not that applied to the reality.
Yeah.
Would it affect the result? And after this, how would you validate your result? Do you, let's say, triangulation? Would you interview the insiders from, I would say, like out of the case, which identity you would, for example, you want to try validate, let's say from a qualitative approach, do interviews, questionnaires, consultations to the like the experts or think tank in China. Since the data you are dealing with is sensitive, how would you validate? Would you still validate based on your previous data, or would you validate to ask the opinions from the insider?
Yeah,
It makes that clear.
No, absolutely, and I should have put this in my golden rules. Is indeed triangulation. I mean, to an extent, because I dove very deeply into this missingness problem, right? I know, generally speaking, what data is more reliable and which is not. So I tend to only focus on areas, these kind of pockets of good quality data, where I know that my data tends to be more reliable. So I look at the types of documents that I know are more reliable, that have fewer missingness, and some and the ones that have greater missingness, so to speak, I try to not include in my analysis. Or I focus on the topics where I know transparency is higher. With the example of the CAC, for instance, the cyber regulations, where I did the similarity analysis, there is a legal requirement for them to be made public. So I know that there's no missingness. But if you don't know if there's missingness, indeed, it's about triangulation. It's, I mean, that can be surveys, that can be reading academic articles in Chinese, that can be, just going to China, interviewing people, can be all kinds of things. And I think perhaps the point that you're getting at is these types of methods can never replace going to China, doing field work, and all of that. I think they can be a useful complement to it, but they can never replace, because in the end, you're going to need to validate, indeed, as you say, that what you see based on incomplete, missing, problematic, messy, whatever adjective you want to give to it, data, is still reliable. And that involves the kinds of approaches that you mentioned. So in my research, I primarily do qualitative document reading. I read a lot of Chinese academic articles as kind of like a proxy for what's happening on the ground. I triangulate with news sources that I can find within China. So all my research is still from afar. But I occasionally travel to China and simply ask people like, hey, this is my impression. This is also what you're seeing. And so far, I've not had any problems where I noticed that something that I saw in my data was totally not reflected in practice. But perhaps that is because of all these cautions. The book that I wrote is almost entirely qualitative methods, not quantitative. You definitely cannot do without that. Does that answer your question sufficiently?
Yeah, I'm just curious, like the results published, then the reviewers and also the readers will tend to buy or how to say
the data
conclusion, yeah. But the Chinese say we don't buy it because this is from the data set that you select. It's not validate. How to say, like we don't tend to.
Yeah. Simply, these documents do not represent reality, essentially, a paper reality kind of. Yeah, no, I mean, actually, I think the reviewers that I've had in most of the things I submitted, the reviewers were actually also critical of like, what can you conclude from your data? What is this missingness problem? I think in most cases I was able to show that, hey, I'm not taking these documents on face value to represent implementation, right? For instance, so I'm seeing them as communicative acts between the government, not as reality. So that's then a question of how do you interpret these kind of documents. I take a lot of caution in that. Again, reflecting on how these documents are produced and being used. And then I take a lot of different measures to make sure that this missingness problem is as small as possible. So by focusing on document types, as I said, that are relatively transparent. And so far, yeah, I generally have the impression, again, also with Chinese colleagues that I speak with, that as long as you apply a lot of caution, you can get something useful from it. You have to be careful of not presenting it as, the next big thing since sliced bread or something. It's not gonna be suddenly turning truth from anything of that sort. But with a lot of caution, I think you can get far. But that caution is so important. Yeah, triangulation, cross-referencing. Yeah.
Just a couple of yes or no questions. I know that you said you were not going to get nerdy, like technical values, but I mean, you mentioned one word, Python.
Mm-hmm.
So my question is just for everybody that asks.
Yeah.
Is Python difficult to code?
Mm-hmm.
It's difficult to code in Python, sorry. Is just Python enough to do this kind of awesome stuff you saw to us? And finally, you also mentioned downloading somebody else's code.
Yeah.
Do we have to acknowledge that when we do that, or just take it from the web and make it dance for us?
Glad that I can talk about my nerdy stuff as well. Is Python difficult to learn? If I can learn it, you can learn it too. Is my answer.
I'm not sure about that.
Actually, I've heard it. A lot of people learn Python. It's kind of like the first step.
Yeah.
A
So.
lot of people, I haven't done it myself, but actually, like a lot of people that don't come from like an informatics background is the first one they use to introduce themselves into the coding.
So you guys have no excuse.
Love it. No, I mean it's true. So I started learning in January 2020, obvious reasons. I ended up taking a month of about an hour or so per day to get all the basic syntax, just like a language, right? Syntax. And then it took me about a month of practice to write a web scraper for Weibo. So to be able to download all data from social media platforms like Weibo automatically. That took me about a month. There was a lot of trial and error, and that was before ChatGPT. Now, I'm really not kidding in the sense that if you live in Silicon Valley and you're trained as a data scientist, your job prospects suck. And that's because of ChatGPT. ChatGPT has improved the productivity of all these other tools of programmers by 300, 400%. And I'm not exaggerating. ChatGPT sucks for many reasons, but not for coding. So it's become a lot easier. So there are a lot of online tools. I used Codecademy, which is quite playful kind of tool. It's a bit expensive, I think €35 per month or so. Codecademy, as in coding academy, but Codecademy, shortened. And it's a really fun tool to play around with, and you can see very quickly if you like it or not, right? If you find like, oh, learning what a variable is doesn't interest me, you're done quickly. If you decide to learn it, it helps to have a goal at hand. If you already have something in mind, I want to work towards this. So for me, it was learning how to write a web scraper. Because then everything that you learned, you can start to think of, oh, I'm learning now what a list is. I might use a list in this sense. I'm now learning what a loop is. I might use it in this way. So that would be my practical tip. But overall, I think it's shockingly easy. And now especially with generative AI tools. So I remember your first question, not your second.
Yes. Do you have to acknowledge the code that you download from somebody else's page?
So acknowledging, that really depends on the license under which it's published. Very often it's published under what's called an MIT license, and that allows free reproduction as long as you reproduce it with that MIT license, again, the same. So you're not allowed to take someone else's work and then suddenly commercialize it. But as long as you continue that license of free and unrestricted use without warranty, you can almost always reuse it. In some cases, of course, it's nice to throw a citation their way. And if there's someone you really like their work, give them a donation or something. But it's almost always free. It comes without strings attached, also without warranty attached. It doesn't have a customer service in many cases. So you're going to need to figure it out yourself if you run into problems. But it's really interesting how much of our entire internet relies on a small stack of open source software that is produced by volunteers. If you look at Facebook or any social media platform is just open source code that they kind of built upon themselves.
Thank you. I think you write about social credit system, right?
Mm-hmm. Yes.
Well, last year I wrote a TFM about the relationship between social credit system, Confucian legalism values, and new, how can I translate that? New vanguard party ideal.
Right. Yeah.
Yeah, and I didn't use this method, so I want to know which categories and keywords would you use in my case?
In your specific case, I of course don't know, but I can tell you what I did with social credit. So my book was actually mostly qualitative, but for Merrick's report, we did a lot of quantitative stuff. One of the things that we did was simply scrape the records of people who were added to blacklists. So to get an impression of who is actually added to a blacklist and what can we infer on how such a system actually works. We retrieved records, we analyzed government documents and classified them by whether or not they were, or by whether they were targeting individuals, companies, or the government, as an example, right? Classification task. These, I think, were the main things that we did with it. We did a bibliometric analysis, which means to say you compare patterns in publications of documents, like which provinces publish the most documents, which periods publish the most documents, information extraction, for instance, about are these documents for trial implementation or are these documents intended to be implemented indefinitely? Those were the kinds of things that I was looking at. Since you're looking at, it seems a little bit more like the normative side, like propaganda, ideational kind of side of things. It sounds then that kind of official documents, policy guidelines would be the kind of thing to look into. Beyond that, I would struggle to think of something on the spot, but hey, feel free to write me an email if you're interested. I'm happy to kind of think, if you have a bit more detail for me, I'm happy to think along with you then.
Okay, so maybe one last question. We have 2 more minutes. Otherwise, we close the session. Okay, so thank you so much, Vincent. It's been a pleasure, and we've learned a lot. Thank you.
Thank you for having me.